This lesson is on square roots. In a previous lesson, you were given the width of a square and asked to find its area. In this example, you'll be given the area of the square and asked to find its width. One strategy you could use to find the width of a square is to divide the square up into unit squares, a unit square having the area of 1. Then you would count along one of its edges and determine the width. Another strategy you could use is to estimate a value for the width to start with, and then use the area formula A equals W squared to see if your answer is correct. For example, in the second square, let's try a width of 5. So what we would do is replace W with 5 in our formula and have A equals 5 squared. 5 squared, of course, is 5 times 5, which gives us an area of 25, which we can see is too large. So we'd need to guess again and try a width this time, which would be smaller than 5. Employ one or both of these two strategies to find the following widths. Take a moment now to do this. How did you do with your answers? Remember, it's very easy to check them. All you have to do is square the answer to see if you come up with the area. Now, an important question for us becomes, what mathematical operation did we do to come up with these answers? What did you do to 16 to come up with the answer of 4? Or, what did you do to 36 to come up with the answer of 6? What is the opposite of squaring a number? The answer is taking the square root of a number. What would the square root of 25 be? In math terms, it would be written as follows. That funny symbol in front of the 25 is called a radical sign and is used when you want to find the square root of a number. 25 would be referred to as the radicand, or the number inside the radical. To find a square root, think what times itself equals the radicand, the number inside the square root. So in this case, what times itself equals 25? The square root of 25 would equal that number. 5 would be our answer, because 5 times 5 is 25. Find the following square roots and fill in the table below. Remember, think what times itself equals the radicand, or the number inside the square root sign. Also, you should recognize all these radicands. These are all perfect squares. Now take a moment to fill the table in. Remember, you can check all your answers very easily by simply squaring them to make sure you come up with that number inside the square root. What taking the square does to a number, taking the square root undoes. When this happens in math, we call these inverse operations. We'll use 8 as an example here. We will take 8 and first put it through our function that squares it, and we come up with a perfect square of 64. Next, we'll put it into our inverse function machine and take the square root of 64 to come up with our original answer of 8. So remember, squaring and taking the square root are opposite mathematical operations.